Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. Thank you. We now discuss the solution of a problem from the section Linear Algebra, and this question has appeared in the CSIR National Eligibility Test held on December 15, 2019. The question is related to quadratic forms. In particular, it is related to the isomorphism of quadratic forms. This question is placed in part C, which is a multiple select question. There can be more than one answer, and the question carries 4.75 marks. And its ID is 187-980-1818. And this question is suitable for all these examinations. Right. The given question is, which of the following statements are true? We are given 4 statements. Options. Option 1. Any two quadratic forms of the same rank in n variables over R are isomorphic. Option 2. Any two quadratic forms of the same rank in n variables over C are isomorphic. Option 3. Any two quadratic forms in n variables are isomorphic over C. Option 4. A quadratic form in 4 variables may be isomorphic to a quadratic form in 10 variables. Right. Let's now discuss the solution of the problem in detail. We recall the following 2 results. Result 1. Two quadratic forms in n variables over R are isomorphic if and only if they have the same rank R and the same signature S. So they are isomorphic if and only if they have the same rank R and the same signature S. Result 2 is related to quadratic forms over C. Result 2. Two quadratic forms in n variables over C are isomorphic if and only if they have the same rank, just same rank. If they have, they will be isomorphic in the case of the quadratic forms over the complex field. Right. We continue the discussion in the next slide. We call option 1, any two quadratic forms of the same rank in n variables over R are isomorphic. Is it true? What do we require for the isomorphism over the real field? We require 2 conditions. One is rank and the other is the signature. But here it is given only just rank. The rank alone does not determine the isomorphism class of a quadratic form over R. And we require the other condition, signature, also. We give the following counter example. Let Q1 is a quadratic form in 3 variables whose canonical form is x square plus y square plus z square. So its rank is 3. And the signature S is given by the number of positive terms in the canonical form, that is 3, minus the number of negative terms in the canonical form, that is 0. So 3 minus 0 is equal to 3. Rank is 3. Signature is 3. Let Q2 be another quadratic form in the same number of variables, that is 3 variables, and its canonical form is given by x square plus y square minus z square. Its rank is 3, right, obviously. And the signature is S is equal to the number of positive terms are 2 only, minus the number of negative terms is 1 only. So 3 minus 1 is equal to 2. So they have the same rank, but they have different signatures. By result 1, Q1 and Q2 are not isomorphic. So the option 1 is not true. We call on option 2. Any two quadratic forms of same rank in n variables over the complex field are isomorphic. Yes, this is true by result 2. Therefore, option 2 is true. We move to the next slide for the discussion of the remaining options. Option 3. Any two quadratic forms in n variables are isomorphic over the complex field. Is it so? Just two quadratic forms in the same number of variables over C, are they isomorphic? No, they should have the same rank. So if you take two quadratic forms in the same number of variables having different quadratic forms, they will not be isomorphic. Over C, quadratic forms are classified by their rank. Let Q1 x comma y comma z in 3 variables is x square plus y square plus z square. Right. This is the canonical form. Its rank is 3. Q2 in the same number of variables whose canonical form is y square minus z square. Its rank is 2. So they have different ranks over the complex field. Therefore, by result, Q1 and Q2 are not isomorphic over C since they have different ranks. So, from this we are saying, in the support of result 2. Therefore, option 3 is not true. We move on to the last option. Option 4. A quadratic form in 4 variables may be isomorphic to a quadratic form in 10 variables. Yes, this may be possible. Now, we take R as the field. Why? Because no field is mentioned in the option. Therefore, we take the real field. Let Q4 be a quadratic form in 4 variables x1, x2, x3, x4. And Q10 be a quadratic form in 10 variables x1, x2, x3, x4, etc. up to x10. Let the quadratic form of Q4 be x1 square plus x2 square plus x3 square. The canonical form of the quadratic form Q10 be x1 square plus x2 square plus x3 square plus 0 times x4 square plus etc. plus 0 times x10 square. Agreed. So, notice that both the quadratic forms have the same rank 3. So, rank is same. And also the same signature, namely 3. No negatives are there. No negative terms are there in the canonical forms. Rank is 3. Number of positives is 3. And the number of negatives is 0. P minus n, S is 3. So they have the same rank 3 and same signature 3 over R. So we apply result Q4 may be isomorphic to Q10. But showing the isomorphism, what exactly the isomorphism, may be a little bit difficult in this case. So Q4 may be isomorphic to Q10. Therefore, the option 4 is true. So combining all the options, the answer to this question is options 2 and 4. Right? That is the detailed discussion of the solution of the given problem. I remember that we have done in the same question paper of 2019, December 15, such a question, similar question, almost two options are same. And using the same results, result 1 and result 2, we have already done it. And if you know those two results, working out this problem is not difficult. In a way, it is an easy question. I am sure that you understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. Please subscribe my channel if you have not already subscribed. We hope to meet you once again in another episode of learning. Enjoy learning mathematics, and I wish you all the best. Thank you.